right, hello and welcome everyone to the second session that we have for Foo-Bar, the Java review sessions. I know we only have very few people online right now based on the numbers I'm seeing on the viewers list. Why don't we wait a few more minutes so that more people can show up, and then we'll continue on. I want to make sure that my voice is coming in properly. Everyone can hear me. My screen is on. Camera's not too off angle. If anyone in chat could please confirm, I would really appreciate that. Thank you very much. I'm good. Thank you. Thank you for confirming that for me. In the past, I've had a few sessions where I perhaps forgot to turn on my microphone, or the camera is not working, and then I realized that a bit too late. So it's good to do this check beforehand. And we have Sabers. Welcome to the stream. Just again, we're waiting just a few more minutes so that we can have a bit more people show up, and so that I'm not repeating the same things over and over again. So we'll give them about 3 more minutes. We'll start at 7:05. Before we do, if anyone has any questions, perhaps some specific questions maybe I can answer in chat, feel free to ask. Now, one of the things that's a bit difficult teaching this way is that when I normally teach, when I normally giving a lecture or a presentation, you get to see the audience, you get to see if people are interested, or if everyone is bored, if people you get to see if some people understand what you're talking about, or if anyone is confused. This way, I have no idea what's going on, and I can't see anyone. So depending on chat is really important. Second, thank you. Sorry, that's just tea going on. You can probably hear in the background. So as I was saying, it's a bit difficult to gauge what the audience is doing at the moment. So if any time I go too fast, or if I'm the topics I'm explaining are a bit too complex, do ask questions in chat, and I'll slow down and I'll try to answer as many questions as possible. At the same time, if you already know the answer to someone else's question in chat, feel free to do so. This isn't like a regular classroom, because you talking is not going to interrupt me, and it's not going to interrupt others as well. So feel free to have discussions in chat. Just keep things clean, hopefully. And that's essentially what I have to say in the beginning. Still, let's wait 2 more minutes. We have Lala CPSC and Sabers in chat so far. There might be other people, but I just don't see any names on the chat server yet. And just confirming, you folks are from University of Calgary Computer Science Department, either CPSC 233 or 219, or just somewhere off the internet. We have somebody from CPSC 219. Awesome. And we have somebody from 233. Great. Now these sessions are pretty much open to everybody because it is an open channel Twitch, but they are more or less related to these 2 particular courses. Now I know the lab has rules which says no liquids in front of the computers. If you do have them, put them in a sealed container on the floor. But I'm not in the lab, I'm at home, so I'm not breaking any rules. My house, my rules. All right, 7:05, so let us get started. Welcome once again to Foo-Bar, the Java review sessions. Today is March 13, 2019. My name is Zan Rizvi. I'll be your host for now. And just, let's just jump into it. So today we'll be covering a few of the topics: interfaces, abstract classes, inheritance, polymorphism, method overloading. We have a 3rd session on Monday, March 18th, and that's where I will be covering JavaFX and other graphical user interfaces. I know there was a lot of requests for JavaFX. It's just that I'm not an expert in that topic yet, so I just needed a few days to get a project up and running and then just be comfortable with that topic. But before we jump into the actual content, a few disclaimers that I do have to put out. So first of all, this is my personal channel. It is not part of my TA duties. As I mentioned in the previous session, I'm a graduate student at the University of Calgary. As part of being a graduate student, I have to TA. That's an opportunity that I get to do. I'm a TA for Computer Science 233, but this particular channel, these kind of streams I do is on my own time, just because I enjoy doing them, and I know there's students who prefer more of a lecture type environment rather than a flipped classroom and then just reading on your own. We will be focusing on object-oriented programming in Java, and then essentially we'll be doing reviews. These are more like tutorials than actual lectures, so you may have a difficult time if you're coming in exactly if you haven't studied or if you're not familiar with the content already. This is more of a review session. Once again, the content offered here is related to Computer Science 219 and 233 courses at the University of Calgary, but everyone here is welcome. And then feel free to ask questions and have discussions in chat, as I already mentioned. But try to have a few rules in mind. So offer common courtesy to others, keep things clean, and preferably no spamming, please. And then once we are done with this session, I will post a video of this on my YouTube channel for people to be able to view later. The reason I prefer doing a live stream is because people can actually have questions, and then this could be more of a direct conversation. If it's just a review, if it's just a video that I post on YouTube, then it's just me talking, and I might not actually answer the questions people have. So having a chat here makes things a lot more difficult. I am monitoring the chat here, and I will try to answer as many questions as possible. All right, so to get started, so topic for today, we'll start off at interfaces. And once again, I'll be using Eclipse here to show what's going on. And then hopefully you can see the screen. Hopefully the text is big enough. If it is too small, let me know and I can change the font sizes to make things simpler. So interfaces are components in Java, or components? Well, interfaces are interfaces. They're things in Java which you can use to specify how a class should behave, or more correctly, the features that a class may have. So let's try something here. I'm gonna give it a generic name, my interface. And right away, hopefully you can see is instead of saying public class, it actually has the keyword public interface. Now what I can say here is this particular interface has a few methods. So perhaps I can say like it has a public method. It returns an int, and the method name is foo, and it takes no argument. That's all I'm doing. I'm describing the method signature. And then we have another method like public. This one is void. We call this bar. And again, all I'm doing is describing the method signature. And then I can do this for multiple methods. Now, where this will come in handy is, let's say I'll save this. I'll create a class. Call this my class. And then I'll add the keywords here, implements my interface. Okay, now you can see in Eclipse, I'm already getting an error message here. It's probably saying that I have some unimplemented methods. Now what this means is since this particular class implements this method, it has to implement the methods specified by the interface. So I have to do something like public int foo, make it a dummy method for now, just return 0, public void bar, again make it a dummy empty method. So now any class that implements the interface must have the methods specified by the interface itself. Now the way this comes in handy is if you're working on a project with multiple people and you want to specify what the method names should be, what should be the return types, what should be the argument types. So actually what we can do is just takes in a string. We can actually specify method arguments, and so you can see the change here. again, I'm getting the same error message. The signature has to match with the one in the interface here. So that was saying when you have interfaces and you have a group of people working together and you want to specify what methods should there be, what should be the name of the method, what should be the arguments, what should be the return type, you can use interfaces to make almost a contract to say, okay, I expect you to build this class and it should have these methods with these return types and these arguments. And it takes away any kind of ambiguity, because let's say if we were to just discuss in person that, okay, I want to create a class and it should have these methods foo and bar, but perhaps we don't clarify on the spelling. Maybe somebody spells it with an uppercase F for some reason, and then with an uppercase B here. Now when I save this, and when I go to expect these two particular methods in this class, well, they're not there because the other person spelled it a different way. So interfaces in this way makes things a lot easier, because it's like you're writing a contract to see what methods are there going to be, what would be the arguments of those methods, and what would be the return type. Now notice we're not describing what the methods do. We don't have a method body here, like an abstract method. Perhaps you can write some documentation to specify what the method is supposed to be doing, but it's not necessary. All we are saying in this contract is method signature and the for the required methods. Now, what this does not prevent my class to be able to implement even more methods. So what I can actually do, public, make it Foo-Bat in this case. I can make even more methods if I want to. Let's say this one returns a string. I can have more methods, but the minimal methods I need are the ones in the interface. Another thing I could do is create multiple interfaces. I'm just going to call this second INF. And then this is going to have a method public or Boolean, third method. Now my class can implement multiple interfaces. And it would need to have all the methods from the interfaces. So again, this gave me the body for the third method, which is coming in from the second interface. To go in a bit deeper here, so I'm going to create a class for the driver. This is going to be where my main method is. I'm going to create an instance of my class. Do this, and now I can actually invoke all three methods that I've created in my class, or rather all four methods. So we can see mc.foo, mc.bar, takes in a string, mc.foobat, and mc.third method. But so what's happening here is this is the reference, right? The reference is the variable name here is MC. The type of the reference is my class. And now here's the instantiation of that object. And here is the assignment operator. So what I can do is I can actually just specify a different reference type here. So I can say my interface, or I can spell interface, mi equals new my class. Now the only methods that I can invoke from mi are the foo and the bar. Make this high. I cannot implement, or I cannot invoke the other two methods, the Foo-Bat method and the third method, or the method called third method. And that's because this particular reference is for my interface. Mi is behaving like an object of type my interface. And this particular my interface only has two methods. Then similarly, I can do second interface, make it si equals new my class. Now I can do si dot third method. And that is because the reference type second interface only has this one particular method. It does not have the methods Foo-Bar, Foo-Bat. That's why this is the only method I can call. A thing I cannot do, so I'm just going to try my interface again. mi2 equals new my interface. If I know my history or my programming, this should not be allowed, because my interface is only an interface type. It's not a class. That's why I cannot instantiate it. I can only use it as a reference, and I have to instantiate a class that implements this interface. In this case, which is my class. And now I can create multiple classes, each of those that implement either my interface or the second interface or both. Okay. Is that clear? Do I need to go a bit more into interfaces, or is that good enough? Please let me know in chat. I'll wait a few more seconds if anyone has any questions. From Sabers, we have good enough. Okay, when do you use an interface over abstract methods, or rather an abstract class? That is a great question, Lala CPSC. We use interfaces when we don't have a class representing an actual object. More importantly, abstract classes can do a bit more than interfaces, because in an abstract class, I can define full methods. I can define instance variables. This is something I cannot do with an interface. Additionally, when we so the case you might want to use an abstract class instead of an interface is if you want to have actually fully defined methods, or if you want to have instance variables, which is something an interface cannot do. Another thing to keep in mind is in Java, we can implement multiple interfaces for a given class, but we can only extend a single parent class. So this comes down to your code design, and that means that you may be able to do something like this for interfaces, but you can't do extends parent class 1, parent class 2, and parent class 3, and so on. You can only extend a single parent class, but you can implement multiple interfaces. That is a really good question. Thank you for asking. Hopefully that description clarifies things a bit more. In certain cases where you only need a single interface, and then you might be deciding, should I use an abstract class or an interface? Unless you need instance variables or actually complete methods, use an interface instead. Because if you're using abstract classes, then it's like you're using a sledgehammer to hammer in a small nail. You're using something a lot stronger than needed. It'll get the job done, but it might not be necessary, and it might not be good coding design either. Anyways. All right. That's everything for interfaces. Not abstract, I should say done. This is just to keep track for myself where we are and what we're doing next. So this is a great segue into abstract classes. Let's go back to here. All right, I'm gonna clear off these other classes, and I'm going to keep the driver just because that's where the main method is. However, I am going to clear off this code. Now, abstract classes are classes that are not complete. Then the way we create this are, so let's say I'm going to create a new class, and I'm going to call this weapon. One of the things I realized from the last lecture that the examples weren't really inspired. They were quite generic and didn't really have any kind of meaning. And that's because I don't usually use, let's say, the student university example. When I'm working with these kind of coding challenges, I actually use like fantasy RPG games. So a lot of times the class I go to is, let's say, different types of weapons class. And hopefully I don't alienate anyone here. I won't go into crazy amount of details for these things, but I'll try to keep things simple. But this is an example I like to use it, and it's easy for me to come up with stuff on the fly here. So coming back to abstract classes, this is the way we create an abstract class. We add the keyword abstract between public and class, and this normally behaves like a normal class. So let's say this would have instance variables. So let's say private string, it has a name. What else would a weapon have? So let's just say the most generic weapon, all it has is a name. Well, if you're working with the fantasy stuff, so let's say it has a damage value 2, a base damage value. This is a basic class. And then once again, we can have constructors. And hopefully you guys recall the description about when to use the keyword this. And I don't have to go over this again. We can do this easily. Let's see. One thing in Java, or rather Eclipse makes really simple, is generate getters and setters. And it does this for us automatically, and it follows the proper naming convention. And now let's say we have a so this is essentially a weapon. All it has is it has a name, it has a damage, and just setters and getters for those values. Now in Java, we cannot instantiate an abstract class. So weapon, and then let's just call it lowercase w weapon equals new. I should not be able to do that. It's underlined red, hopefully you can see, and it's giving me an error message saying I cannot instantiate the type of weapon. That is because it is an abstract class, meaning that it is incomplete. There needs to be more information for Java to be able to create that object. And conceptually speaking, when you say a generic weapon, at least in the gaming world, it might be, what kind of weapon are we talking about? So we need other classes to specify different types of weapons, and so we can have more details. So for example, we can create, let's say, sword. Now sword is a more specific type of weapon, so we can say extends weapon, and let's see what's it telling me. Yeah, I need to set the constructor, so I would do the same thing. So public sword string name damage. Once again, hopefully you remember the constructors that we worked with during the last session. Then we can use the keyword super here to instantiate those instance variable by calling constructor in the parent class right here. Let's say a sword can do something a bit more than the weapon can. So we can do something like, and it would have some kind of methods. Public, let's say, void. All swords can attack easily. And this just prints out we get the name, and then we just print out this message, attacks. Okay. Now what we want to do is, instead of instantiating a generic weapon class, we just create a sword. And what am I missing here? Right, the instance variables. We have a good sword name. And let's just make it over 9,000. I know those are two different references, but I'm just gonna make things work right now. So here we have an abstract class. We couldn't instantiate it. We need to instantiate one of its children class, which by definition extends our abstract class. And now this weapon reference behaves like this particular class. It can only do what's defined in this particular class here. Meaning the attack method is not defined in our abstract class. So what we won't be able to do is we won't be able to say weapon.attack. And that is because this particular method is defined in our sword class. Other things we can do is, let's say we can create more weapons. Call this a warhammer. Okay. And then again, this also extends weapon. And while I am writing a bit of code, if somebody could figure out how to spell Mjolnir, I would really appreciate that. All right. Then instantiate the constructor for the parent class, and then also do the then we have the attack method, as well as which essentially prints a has a what method should this one print? Ouch, that hurts. All right, so we have two different classes. One is a warhammer, one is sword, and they both extend the weapon class. So what we can do is, I'm gonna get rid of this one. Weapon 2 equals new. And then I think that's the correct spelling. And give it a name. Give it a attack value. And now what's going to happen is that both of these classes, or rather both of these objects of these two classes, sword and warhammer, they inherit from their parent class. Meaning, even though the name and the damage value are not declared in these two classes, they still have access to those. So we can do something like system.out.println weapon.getName. We can even do something such as create a sword object. Do I have another name for caliber? And then similarly, we can do sword.getName. Now, if we were to run this, it should print the name of our two swords. And that's because even though this getName method is only defined in the parent class, or sorry, the wrong one. Get name here is defined in the parent class, which is weapon. Sword still has access to it in the because it extends weapon. Now the part where the abstract notion comes in is to have abstract methods. So this is something like similar to what we see in interfaces, but slightly different. We have public abstract void attack. So here we are describing or providing the signature for an abstract method which the children classes must implement. Let's just for the argument, let's give it a new name. Instead of just saying attack, call it do attack. And then we see error messages here because Java wants us to implement the abstract method here that we have provided here. So let's just we can add the unimplemented methods. And then let's say we'll have some kind of output that tells us where we are. So this is we can say Warhammer attacks. And then here we can say the sword attacks. Now when we go back to our driver, so recall that initially we could not do weapon.attack, but now we should be able to do the following: weapon.doAttack and weapon2.doAttack. Now let's put them in a print statement. What am I missing here? Oh, sorry, because this particular method does not return anything, it just prints. So I don't need the print statement here. I can say weapon.attack and weapon2.doAttack. And if I run the code, yes, I want to save, it prints out the specific methods that are specified. That is where abstract classes come in handy. That is that you want to specify abstract methods, and you don't want anyone to be able to instantiate an object of that type. So nobody should be able to do new weapon. They need a very specific child class, which is not abstract, that they need to instantiate. Now, is that a good enough description of abstract classes for you folks? Do we have any questions before we move on? Actual inheritance. I know there's a bit of a overlap between these topics. Essentially, that's why I chose them to present them together, because this will remain on a single topic, and there is a high connection between them. All right. Still not seeing anything in chat, so we can move forward, I believe. Done. Now I think we'll be doing these three simultaneously, because once again there is high dependence between them, and just going through examples where we will cover everything. And we've already seen an example of such. Inheritance, we saw the inheritance of the methods from the parent class. Method overloading, we'll see shortly. Same thing with polymorphism. We saw the difference between the doAttack method from the two different child classes. but let's do this in more formally rather. So once again, our parent class kind of shows that we have these particular methods: the get name, set name, do damage, set damage. There's do attack, and perhaps we can add another method. Let's see, what else can weapons do? This would not be an abstract method. Perhaps, you know, if you're working with in a gaming environment, so let's say it can take a turn somehow. Maybe the weapon represents a character and they take their own turn. Now what this does is it takes the damage that it does, that the weapon is supposed to do. Takes the turn. And it specifies how much damage is supposed to, what the weapon is supposed to do. Now what we can actually do is do a bit of a method overloading, or rather method overriding. The wrong word in there. This is, yeah, I think this is supposed to be method overriding. My apologies. Or overriding. I forget how they actually spell it. And then we're trying to override the do damage method. So let's say public, and then the do damage was the return type was int get damage. Now this is supposed to return the damage of the parent class multiplied by 2. Now similarly, in the Warhammer class, instead of saying that it returns damage multiplied by 2, it says damaged plus 2. So now, if we were to do something like weapon dot take turn and weapon 2 dot take turn, what do people expect we will see here? For weapon, would we see the damage being 9001 or something else? 9001 multiplied by 2, which is 18,002. And for Mjolnir, will we see 666 or 668? Get your votes in. Then I'll run the code. Wow, we really have a really quiet bunch today. All right, if just want to wait, do it. So we run this, and what we see here is does damage 8,002, or sorry, 18,002 and 668. Now, why is this the case? This is because we're doing a bit of method overriding. Here we say take turn does damage, and then whatever value we get from the get damage method. I notice that this is, we have the get damage method here, but it's not actually calling this one, because the damage values that we've put on before were 9001 and 666. It's actually calling the get damage method in the child classes. You know, it being multiplied by 2 here, it being added by 2 here. I think if we wanted to get the original value for this, we can do something like this dot get damage, and I think it'll prevent it from nope, it's not even doing that. I think what if we wanted to prevent it from being overwritten, we use the final keyword here. I'm just going to comment this out for now. Right, because what this will do is yeah, you cannot override final methods. So if we want to say that no child class can override the method that we have here, then we use the keyword final. Extra tidbit of knowledge. But otherwise, it's going to call the methods in the child classes. And the way it finds out which method to call is it looks at the object being instantiated. Now, we can consider this as two different things. The weapon here is only a reference. Sorry. Now, this here is only a reference, while this thing is the actual object being instantiated. This is where where everything is stored, where the instance variables are, where the access to the specific methods are. So when it says the get damage method here, it looks at the object being stored. Here in this case it's the type sword, so it'll call the get damage method in this case, the one here, and that's why we see the output value of 18,002 and not 9,001. Okay, and then the question is, why would you use final? Couldn't you just not make an override method? That is again a really good question, Lala CPSC. When would you not want to, or rather when would you use method? This is the case where, let's say if you're working with a bunch of code, again, if you have a group of people that are working on the same code, and there's not always clear communication between everyone in the group, or if you are creating some kind of library, some just code base that you're releasing online, and you don't know how the other person was going to use it, and there are certain things that you want them to remain as is without anyone being able to override certain methods. So that's the case where you would want to use final to make your methods final. Another way is just so that you don't make a mistake yourself. For example, if I'm working on a bigger project which may last months, maybe even years, I write this particular class and I tell myself, I'm just not going to override this method right here. I'm just not going to override it. But some time passes, I've forgotten what I told myself all that time ago, and then when I try to create something new, I do end up overriding the method and some other things fall apart. So this is more of a way to communicate with others and even yourself, a bit of sanity checking, and this is just just making sure something won't go wrong. You can trust other people's as much as you want, but sometimes you just want to make sure that that people aren't going to do the wrong thing, even by accident. So that's why we would want to make the methods final. So we've talked about inheritance, we've talked about method overriding. We've also kind of talked about polymorphism, but I'll touch base again. And that is when we call specific methods, we can see right here, or just to go step back a bit, we can create weapon references and actually instantiate different types of objects, or rather different child objects. So in this case, we're doing a sword. In this case, we're doing a warhammer. And if we had other classes, we can instantiate those, but notice they have the same reference, which is of type weapon. Additionally, when we call methods, like let's say the abstract methods that do attack, Java inherently knows which actual method to invoke based on which object was instantiated. And sometimes you don't want to worry about that detail. Maybe this is coming from somewhere else. Maybe it's a library that someone else created. Maybe it's something that the object that you get is of type weapon, and you don't care about the details. And all you want to do is just worry about the weapon class, and someone else is going to take care of this part. This is another way inheritance and abstract classes come in handy, as well as polymorphism. Now, when you actually call the do attack methods, it's going to call the appropriate one based on whichever class is instantiated in Java. Also, when you do method overriding, something like this, again, instead of calling the one in the specific class, it's going to call the one in the child class based on which child class is being instantiated. So as we saw here, This one calls the one in the sword class. So this is weapon 1, or rather just the weapon right here. It's of type sword, which multiplies the damage by 2. Down here we have weapon 2, which is of type warhammer. And here the get damage method just increases by 2. So it calls this particular method here for the weapon class, which just changes the damage value from 666 to 668. I think that covers the basics of what we've seen about inheritance, polymorphism, and method overriding. Is there something I missed? Does anyone have any questions? Please let me know in chat. Otherwise, this was all we had planned for today. And one thing that I would appreciate for you, if you did, there is a link to to a survey in the description of the channel. If you would follow that and please fill out that survey. If you filled out the survey on the Saturday session, you can, I believe you can do this again, but this one would be about today's session as compared to the previous session. I would really appreciate it because it's going to help me understand how to make the channel move forward, what are certain things I can fix, and what are things that I can get rid of that are not needed. I'll just copy the link again in chat if needed. Right. Once again, any final questions and or comments? I'd also like to remind you the third session, which is going to be on Monday, March 18th, again starting at 7 p.m. I will be covering JavaFX and a bit of graphical user interfaces with JavaFX, and then slightly discussing the model view control, which a lot of us need for our projects so that we can separate our logic components with our interface components. And that'll make our lives much easier. That session is probably going to be a lot, not a lot, but like slightly longer than this one because JavaFX is quite big. The example that I will cover might be a bit detailed, and that's because I know different people have different types of projects. So I would like to help pretty much as many people as I can. Instead of covering just a single type of project, I'll cover multiple types so that everyone feels that they got something from the session. And instead of writing the code beforehand, I will continue my trend of writing the code as I go along in the tutorial, and that's because I find these types of sessions a lot more interesting. Because if I wrote the code beforehand and then just described what was going on, I might go a bit too fast. You won't get to see the mistakes I made. And a lot of times, the best time we learn is seeing mistakes and then see how we correct them. So that's why I like to code on the spot. I may make some notes beforehand, but the actual code I will be writing on the spot here, which again increases the time. And Lala CPSC, thank you for the videos. They are really helping. You're welcome. I'm glad you find them helpful. As I mentioned earlier, I enjoy teaching, and the reason I do this is actually if people do find them helpful. Otherwise, it's just me talking into the ear. So comments like these really makes me want to do more of these sessions, and I'm happy to do so. All right, and if that is it for tonight, if there are no other questions, I will see you folks next time. Thank you for attending, and good luck in the future.